First, I should point out here when I give talks like this, of course, as a professor, you know, I have my cooperators, meaning the students and the RAs and postdocs, and they are heavily involved in the stuff you're going to see now. So when I say I really mean we, and if I say we, I really mean they on that. But of course, I'm going to stand here and take the credit for it. So I'm going to talk about vegetation with a focus on late successional structures. So tying a little bit, I guess, Rob's talk about old growth and looking at our thinning studies and saying, well, what kind of vegetation components, vegetation structures do develop and how do they relate to what we see in old growth on that? So I'm going to talk a little bit about the overstory, a little bit about tree growth in a little more detail, then focus on regeneration patterns that we see in our thinning studies, understory vegetation, and give a special attention to gaps on that. You know, Rob already set the stage nicely for me as a component of bringing in spatial variability. And one thing I want to make very clear, of course, is a lot of the results you see are short-term results, and Mike already hinted that there are some long-term dynamics we need to consider when we interpret short-term results. So I'm going to jump right into it, and this is kind of the pattern you will see. I'll bring in some graphs so you can see that the numbers are real, and maybe get some idea about the scale of differences, amount of differences. And then I have down at the bottom somewhere this yellow box with what I consider the short take-home message. But I should point out that the take-home message, of course, is a generalization on that. And one thing you'll see at the end, actually, there is a handout there, and there will be information in the GTR. I do put in the citations. A lot of these, you know, brief three-word messages have a full set of experiment and analysis behind it. So I know I generalize, and I know that you'll find exceptions to any generalization I make on that. So the first one you'll see is we're just looking at canopy closure on that. So this is not canopy cover, you know, which is kind of if you look down from the top. Canopy closure is when you look up and kind of look up in a cone. So canopy closure values are usually a little higher than canopy cover values. But I think the trends would be very similar. So you can see actually up there the black line, the control, a typical dense forest here, this is on the Youngstown Thinning Diversity study, has about 80% cover. There's enough wind to keep some openings up there. When we thin it, of course, we reduce it, and the heavier we thin, the more we reduce it. But to me, the important message is what Mike already hinted. Those forests are very dynamic, and they're going to close back in. So when you look across the region, the rates that I've seen with various studies, it seems like 1.5% to 2% annual closure rates on that. So if you thin down to 50% canopy closure, within 10 years, you're back up in the 70% area. So quite dynamic. And this kind of the rate and the dynamics you have to keep in mind when you deal with Douglas fir stance on that. I want to talk about tree growth just a little bit. This is the only slide I did not convert to English units. I apologize for that, but I want to set the focus here up on the upper right corner. On that, that's the Douglas fir growth. And of course, if you thin, average growth, diameter growth increases, no surprise there. But if we start breaking things down a little bit more in detail, we see some trends that I think are important to consider when we look at developing old growth characteristics. And the main thing I want to point out is the lower line here is the control, and these are various thinning treatments. And I want to focus your attention to the upper right of that graph. That means the biggest trees in that. And what you find out, of course, the big trees are growing faster than the small trees, even after thinning. But the big trees don't seem to really get that big benefit from the thinning operation. They already grown at full potential on that. And you know, with some spatial variability thrown in the mix, the most thinning operations, unless you get to the very extreme, and I'll get to that a little bit later, you don't really help those big trees that much. So if we look at some of the old growth index that Rob used, you know, so many trees about 40 inches, our standard thinning operations are not pushing the stand along quicker on that. Even though we grow a lot of smaller trees, they'll benefit and they'll come along. but those top trees, the top 10 per acre, see less of a benefit than the other trees will do. You don't see that with hardwoods and hemlock on that. I want to briefly talk about another component is the idea of multiple canopy layers and how the crown moves up. What you see here on this graph is the height at the base of the life crown. So you're looking at, I think, Eric, 120 feet tall trees. On the left is the control and then various thinning treatments, and the further right you look, the more intensively the thinning treatment is, I guess, to simplify this here. But what you see clearly is that there is a benefit in terms of maintaining crown and life crown ratio to thinning. I guess no surprise there. The textbooks tell us that already. So, but it also points out, of course, that if you come into a 50-year-old stand, you're already looking at conditions, at best, you already have 60 feet of clear bole at the bottom, which is a real good thing if you want to sell the timber. If you're interested in wildlife aspects, you know, having branches that have mosses and lichens at lower levels, obviously you've already lost a lot of the gain, unless you get some epicomic branching where the crown come back down. And you do get some of that in Douglas fir, especially when you open things up quite wide near gaps. Switching to another component of old growth and looking at stand structure. Here you see a diameter class distribution, so the number of trees over a tree size here. And the control conditions that's shown here, you see that we have the typical normal bell-shaped distribution, which is what you expect. Now when you thin, after the thinning treatment, actually this is measured 10 years later, you see that the 3 different thinning treatments in the density management study already lead to this, what you would consider at least a bimodal distribution on that. So there's fairly quickly and fairly early, you see this shift. Now if you look closely though, you'll see that, you know, you didn't really change the number of trees, so really what we've done, it's a chainsaw effect on that. We've taken that stand and cut it into a bimodal stand on that. So there is a trend there towards potentially having a diameter distribution that doesn't reflect that even-aged normal distribution, but there obviously has to be a little bit more to it. And now let's look at the next few slides. I'll talk about what happens here at the lower end or even below the lower end of this diameter distribution. We had a 2-inch cutoff here for this measurements. So looking at tree regeneration, I figured Mike would talk a lot about planted trees, and so I'm going to focus on the natural regeneration. And one thing you'll see here, if you look at the control and the various thinnings, all of them have, I think if you follow our average standard of 400 trees per acre, all of them have sufficient regeneration on average to consider the understory fully stocked on that. But of course, what happens with natural regeneration, you have an extreme wide spatial variability. So you find plots that have 0, and you find plots that have 10,000, especially when hemlock gets in the mix fairly quickly on that. So the spatial variability is a key factor in it. And if you remember Rob's talk about old growth, he made a big deal about bringing that spatial or the importance of spatial variability as an old growth characteristic. So we see that in the regeneration patterns. If you look at actually species diversity of the regeneration, I want to highlight, John mentioned before that in the treatments they left the minority species, and I want to highlight that shows up in the regeneration. Seed availability is a key factor. So if you leave that occasional hemlock, if you leave that occasional cedar, that occasional maple, even chinkapin, you see that reflected in the regeneration after thinning on that. So there is some potential to bring other species into the mix more. Or I guess you could look at it, there is some potential that other species take away from Douglas fir. Getting out to saplings on that, we found the same effect of saplings. These, of course, are trees that were probably regenerated before the thinning took place. And what you see with saplings, clearly, in the control condition, we have very little. And that's kind of what this message that Mike already had. We get a lot of germination, and then what happens to them, eventually they'll die out unless we give them room. If you give them room, we have saplings that will keep growing on that. Of course, they won't grow as fast as the clear-cut conditions, but then if you think about it economically, the big trees are still growing there too, you know. So in that sense, there is some trade-off that we can see. The one thing, actually, the patterns that you see here, and you've probably seen in other slides too, the big difference always seemed to be thinned versus unthinned. The thinning treatment itself didn't really sort out that well, especially once you throw statistics at it. And part of that, of course, is the high variability that we find in those conditions. But the one thing I want to point out, and Mike has kind of nicely set the stage, that I think the major challenge in terms of managing these stands is to deal with the regeneration and to be able to maintain these desirable trends, both in terms of understory vegetation, which I'll get to in a minute, but also in terms of regeneration. Getting beyond that thinning idea to the management of those stands in the long term, and the regeneration story will be the real kicker to make that work. And in our experiments, we've kind of set in motion, at least in the plan, that we're going to PCT some of these stands, especially where we have hemlock. We have way too many, just like Mike pointed out. And so we'll be thinning them down, and we'll be thinning them down till probably 80 trees per acre or less is in the plan. So something that's low enough that it'll allow for other vegetation to still be in the mix on that. And even 80, actually, after looking at things and walking through the woods there, looking at our last thinning entry, even 80 is probably too high. Next point, actually kind of tying it into the diameter distribution, if you look at the trees that were ingrowth, so that 6 years after thinning, they were less than 2 inches. We didn't count them. We didn't measure them specifically. We counted them, I guess. And then 11 years after thinning, they had broken that 2-inch barrier. So they show up in the diameter distribution. And here, again, you see the same kind of pattern in the control. Very few trees that are growing actively enough to break that diameter distribution. When you thin, you do see an increase. These trees, while growing slower, they are still growing on that. And here the thinning treatments kind of separate out on that, and I think that's kind of maybe already the long-term aspects kicking in. That if you go to a high density and to a moderate density, you see a difference in growing patterns on that. So tying this back together, while I pointed out that the diameter structure here, the bimodal structure, is mainly driven, at least initially, by the chainsaw effect. If you followed my story about what happens here to the left side of the 4 inches, you can see that the potential of having this multimodal distribution clearly is there. And maintaining it, if we want it, that'll be the challenge in the future, as far as I can tell, in terms of management. So I'll cut through a few other vegetation components, focusing on, well, I guess, things other than trees on that. And Leanne Baggs is here. She worked with the first 5 years. Leanne Davis worked with the first 5 years. We have some 10-year data now of that, and I want to go through various structural components and just highlight some of the trends we found. The first one is when we look at shrubs on that, the control conditions in the Youngstown Thinning Diversity Study, about 40–45% cover in shrubs. When we thinned, we dropped it, we lost it on that. So quite likely due to harvesting damage on that, obviously dropping the trees, dragging them around. Some impact on the taller shrub, the wine maples, the hazels, ocean sprays. And then we see a fairly slow recovery. 10 years later, it's not statistically significantly different, but it's kind of back almost to the control level. So this is kind of an example. The idea was with thinning, we're going to accelerate late successional development, and shrubs are an important component of those. Turns out that, at least in the short term, the first decade or two, our treatments just do the opposite on that. We set it back and reduce that shrub layer on that. And it takes some time till the added light and nutrients available to the shrubs are reflected in the shrub layer. So this is really one where I think I I want to point out, this is probably a challenge for the logging engineers. I've talked with Lauren Kellogg about that. If you're really interested in that shrub layer, part of the logging layout should be to look at where do you have patches of tall shrubs, and can you design your logging to protect that? Which I think should be a little easier now that, if you bang up a tree and create a snag, we take credit for it, right, now, and harvesting. So rather than designing logging systems to look up at the trees, I think certainly if you're interested in the shrub layer, it makes sense to look down at the bottom and lay out the logging operation to protect the shrub pockets at least. If we go to other components of understory vegetation, the herbaceous vegetation, it really didn't see much difference. It kind of sorted out initially after the first year after the thinning operation, but then fairly quickly it's so variable. And the herbs really are not that dynamic, at least in terms of cover. And I think partially what they see is, by the time they get going, the shrubs are recovering, the trees are recovering, the regeneration is kicking in. And they seem to be at the low end of the totem pole on that. One thing I want to point out here is, of course, vegetation is not equal vegetation, and 50% cover of shrubs is not equal to 50% cover of shrubs. And one of John Tappener's cooperators published a paper a while back where they looked at a few of these study sites and looked at the flowering and the fruit production of those shrubs. And clearly we found when you open things up and they get more light and they get more resources, we see an increase in flowering and fruit production of the major shrubs, and actually I suspect also of other flowers that you find in those forests. So and there is another whole suite of characteristics that follows a similar trend. If you open things up, you'll have thicker leaves on the vegetation, probably higher protein content. So, a plant is not equal to a plant, so there are lots of other benefits that our standard measures of shrub cover don't capture on that. And I also want to point out, of course, that a new regenerating wine maple doesn't have the same ecological impact as a wine maple has. That's been there 40, 50 years and has been covered by mosses and lichens, and insects are in the mosses and lichen, and birds can feed on the insects in the mosses and lichen. So keep in mind, again, when we talk about that, those are really almost two different animals, and to me makes another pitch for protecting some of those established vegetation components. Bryophytes, just quickly, this is ground cover bryophytes. We found an initial effect. There's a higher cover right after thinning, quite likely covering up those skid trails, so that first disturbance layer there, and then kind of settling in, and we don't see a big difference between the treatments anymore. Another component I want to make out, if we go from cover and look about species composition, who really benefits from thinning? If you look at this again, the control versus various thinning treatments, it's that gray box up here. It's the early cereal vegetation on that. It's the grasses, some of the thistles even, and those kind of species that clearly kick in. So again, as we kind of think about thinning design to accelerate development of late successional forest, in terms of species composition, actually just the opposite. We increase the component of early cereal species, but then again, if you have followed the discussion about early cereal vegetation, maybe that's a good thing. Maybe this means we have pockets in the forest that maintain that early cereal vegetation in an old growth dominated landscape. Another point I want to make, you can't talk about vegetation without talking about exotic species. We found very slight increases, but if you look at the scale, bumped up from 0.3 to 0.9%, very minor. We had one site here, I kind of broke it, or Leanne actually broke it down by sites. One site where we had a major increase, and that's really right next to a dump down in Mill Creek, where the city dump has a lot of Scotch broom, and it spilled over into the study site. So it seems like to suggest that if you have a weed problem already, yes, then thinning may become more of an issue. If you look at standard forestry operation, The increase in exotics is very minor. And those exotics are, at least for the most part, as we've seen, not invading. They kind of disappear again. When we look between year 5 or 6 and 10, the trend of all those exotics is going back down. So they're not taking over the landscape. Now, we don't have false brome in our study site as Mike has. I think the story would probably be a little different. I'm going to focus on gaps as one other component here to increase spatial variability. And when I focus on gaps, starting with the trees, I want to point out is that this is now when you see a benefit of really opening things up, of thinning on that. You know, the ultimate thinning is, of course, to remove all trees. And the trees adjacent to the gap that have basically crown exposed to the gap, they see a big kick in terms of more light and more moisture and more nutrients. I assume, I guess I haven't measured it, but quite likely, because they really respond in growth. So we found on average a 40% higher growth rate on those trees that are adjacent to the gap. And this is not reflected in our growth models. If we do the simulations on that, you know, most models we use assume an even spacing on that. So you got to be careful if you take out in your simulation, you know, the area in gaps, like all these studies have, like 10% area in gaps. If you just subtract 10%, you're not doing the tree growth justice on that. There's partial compensation in the gap scenario. But gaps is really where you see the big changes in vegetation composition on that. So when we look at thinning, and yes, you know, the understory changes a little bit, but if you really want to make an impact, you can't be subtle about it. You need the gap on that, especially with those dynamic Douglas fir forests we're talking about. One thing I should point out, when we looked at least in the short term, a few years after, does the vegetation kind of the gap influence the neighboring forest? Do you see that creep? So you have a 1 acre gap, and then we thought maybe it influences an 1.5 acres or 2 acres. That didn't seem to be happening, actually. It seemed to be very limited. By the moment you walk outside the gap, the vegetation was very similar to the interior forest. So at least in the short term, there's very little creep, so to speak, from the gap in there. We also found that actually the gap itself wasn't that important. There were a couple of components that actually, you know, make up the gap as far as the plant's experiences. And one of them is the physical disturbance. So to get the really early VD species, the grasses and the thistles, it's the ground disturbance that is the influential factor there. For other species, cereal species, we find it's a combination of ground disturbance and more light. But the grasses and the thistles and those kind of VD species, they'll come in even in small gaps. And the light really, the benefit of added light is not that crucial for them. They'll be there for the first few years. On the other hand, some of the other species, of course, gap size is important. And the biggest gap in our studies were about 1 acre. And I think if I lay out another study, that's probably where I would start. We really didn't see, if you want to change vegetation composition, the 1/4 acre is very small on that. And you don't get as much of a stratification in the vegetation. And quite likely, of course, it doesn't last as long. One thing I want to point out with gaps on that, I want to bring in the scale issue. When we do a gap analysis and we compare the condition inside the gap, walking into the adjacent forest, we of course find that even in the short term, quite a divergence of vegetation. If we do the same analysis on the stand level, if we take average conditions of a stand with gaps and compared to average conditions of a stand without gaps, we don't see that impact on that, even if you have quite a few gaps in the stand. So this kind of really points out is if you do some assessment and, you know, we say, well, what's the role of gaps? Well, it depends on, if you have a songbird that integrates across 50 acres, they may not experience those little gaps in there. On the other hand, if you have a small mammal that lives in the gap or right near it, they see a big difference when you create that gap. So there is a scale effect of you know, gaps in terms of whether, you know, it makes an impact in, you know, vegetation structure or not. So I know Paul is getting the picture ready, so I'm kind of getting to my last summary slide here. So I just want to point out one of the a few points. One of them I kind of skipped over, but we find differences of thinning impacts, and one part of factors driving that are the initial conditions. For example, where we didn't have much shrub layer before, there was less harvesting impact on shrubs. Of course, if you don't have it, the trees can't crush it. But you do have it, you see that the harvesting impact sets back the vegetation. So if you think about the role of harvesting, it'll vary in terms of the initial conditions. I also want to point out, as I've done, I guess, just saying whether thinning will accelerate development of late successional features depends on which feature you're looking at. Some of it will, some of it will go counter. The dynamics are different in terms of how quickly they respond and how quickly their response disappears. Overall, you may have noticed when you look through the slides, I really wouldn't spend that much time worrying about whether you leave 60 trees per acre or 80 trees per acre. The fact that going in and treating it, that's what makes the difference, at least in the short term. This is clearly where the long-term story will change. In the long term, it will make a difference whether you knock it down to 40, 60, or 80. And I want to stress that to really bring variability, spatial variability in these stands, you need something like gaps. And you need something like larger gaps on that. And the last thing, I guess, I just want to stress again that these are short-term results. The challenge will be how to maintain some of the desired trends in the long term, and especially the challenge will be how to deal with the regeneration that establishes underneath. Thank you.
One or two questions?
Everybody except Mike.
I'd like to have you give us the last chapter of both of our presentations. We looked at stuff that we do between the time of establishment and 70 years or such matter. What happens to all of this when you have to leave the woods at age 80?
Yeah, that's a good point. We have some stands, actually we have one of our study sites has now reached that age 80 on that, and we actually had the last entry, I think, at age 79. And I don't know how that was exactly calculated, but we just made it under the 80. I think when I looked at that stand, we were down to about 35 trees per acre. They had been thinned before. They had large crowns in the overstory. We had quite a bit of understory regeneration in there. And looking at it now, I wish we would have thinned it a little heavier on that to leave it alone. But we can manage the understory, and I think the challenge down the line will be, we have the big trees, some of those will become snags, according to our study plan. If they don't die on their own, will help out in 10 years. But the challenge really then will be how to manage the understory. On those we can enter, at least that's my understanding, when the overstory is 80, we can still manage the understory. And so managing the understory in a way with some thinning operations to maintain that, I think is one of the crucial components. But clearly, I mean, let's face it, if you look at Oregon and look at old growth, if you leave it alone, eventually it'll be a forest, Douglas fir, hemlock-dominated landscape with some holes and pockets in it. And that's, I think, where the gaps kind of come in. The gaps will maintain some of that spatial variability, and it'll be a long time until those gaps are filled, even though, at least for these studies, the gaps were planted at the time, and we didn't do any weed control. The trees will make it through, at least in most gaps, they will fill up, but a lot slower, and we'll still have some pockets where we have hardwoods and other vegetation dominating. So I'm hoping that the gaps in that sense will all maintain some of that variability and some of those conditions for a lot longer than our standard thinning operations will.
Okay, I'm a little bit curious. It sounds like, and I don't know a lot about the density management studies specifically, but it sounds like you thin to 60 trees an acre and that'd be relatively evenly spaced within that 60. And then in the gaps there'd be nothing. And then you have benefits from that. I'm wondering if, say you did 60 trees an acre but really had more of a variable arrangement of the stems. If that would maybe perpetuate these benefits or enhance the benefits, and then what trade-off that would have for timber production. The assumption, I guess, has been that you want evenly spaced crowns to get full site occupancy and maximum production, and I don't know if that's been measured or quantified.
Yeah, actually, I should point out the beauty of these large operational studies is that we can get a handle of variability, and you think things are evenly spaced, and then when we start looking at a plot-by-plot variability, it just blows me away how those densities overlap, and even overlap with the control conditions. So even in the control conditions, we find a wide variety of spacings, and we find the same thing after thinning operations between skid trails. Of course, we had some leaf islands and these as well to kind of maintain the full site. But again, as I pointed out, when we look at the different thinning treatments, they didn't vary that much. And so I'm not sure if you really wanted to push that spatial variability or the variability in composition, I think you still need those openings, no matter how you arrange the other trees. You know, whether it's 40 or 60, I'm not sure that makes that much of a difference on a localized scale, but whether you have an acre gap, that will show up a lot more.
Nice. So some would argue that what was done in the 80s in terms of 10, 20, 40 acre clear cuts on the landscape provides spatial variability. And what I've heard you say is, you know, what we've been doing is more in the quarter acre variability. What, based on what you're seeing in terms of the landscape size, and even these density management, if you look at the entire package, there's variability within that package. But with these gap openings, what size are you thinking we need to go to in terms of the...
Well, if you want a number of which size is the correct one, of course, you won't get it from me. But I know one thing, I guess. I'm pretty comfortable to say that one size doesn't fit all on that. And Rob already pointed that out. If you look at these old stands, you find some single tree gaps in there. You find some larger openings in there. And so if I look at the landscape and look at some of those historical patterns, you know, you need all of them. You need some spatial variability on the small scale, and you need some spatial variability in stand sizes on that the landscape scale. And depending on your emphasis in terms of which species or which visual quality you're after, you know, one mix may fit better than the other. But, you know, at this stage, I would say it's important to look at variability at all spatial scales and make sure you have them at all spatial scales.
Great. Thanks, Klaus.